Recall that a traditional application is one that you can run in your data center or on AWS without making any changes to the code. But once we broke our hypothetical video processing application down into two microservices and started using SQS to enable loose coupling between those services, our application no longer met the definition of a traditional application. When we modified the application to use specific AWS services, it became a cloud-native application. A cloud-native application is one that depends on some resource that is only available in the cloud. In this case, SQS is a message queuing service that is only available on AWS. There is no exact on-premises equivalent. We can't download SQS as a software package and install it on a server in our data center in the same way that we could install a SQL server or a load balancer. This raises an interesting question. If we're already re-architecting the application to get better scalability and performance, then could we perhaps re-architect the application even more to take advantage of other AWS services in order to get even better performance? And the answer is absolutely. Some people call this architecting with services instead of servers. But here's the more relevant question. Will doing so give us better availability? Surprisingly, the answer is no. To understand why, let's look at how you might re-architect the application to use a variety of elastic AWS services. Here's what it might look like. We'll use three main services which I'll briefly introduce and then we'll go into more detail. The Lambda compute service handles the video processing functionality. Simple Storage Service, or S3, provides storage for the video files and static web hosting, and DynamoDB serves as the backend database for the app. These are elastic managed services. AWS is managing all of the infrastructure, so we don't even need to think about it. But what's the availability of our application using this cloud-native architecture? All of these services represent hard dependencies. If any of these services fail, the application becomes unavailable, so we need to know the availability of each service. All right, let's start with Lambda. Rather than running the video processing service on an EC2 instance, we can just rewrite it as a Lambda function. You'll often hear Lambda referred to as Amazon's quote-unquote serverless compute service. It's really not serverless because obviously the code has to run somewhere. It's just that Amazon manages the servers and you don't get access to them and you don't have to think about them. The way Lambda works is you create a Lambda function with your application's code, tell Lambda the language your app is written in, and then you simply call the function whenever you want to run it. This is also called Functions as a Service, or FAS. Lambda can support a lot of languages: C#, Java, Python, Go, PowerShell, lots of stuff. Lambda's availability is 99.95%. Now for storing video files and web assets, things like HTML files, JavaScript, CSS, etc., we can use the Simple Storage Service, S3. S3 can do static website hosting, so it effectively becomes our web front end and eliminates the need for instances running a web server. The availability of S3 is 99.9%. What about the database? We can use DynamoDB, which is Amazon's non-relational managed database service. This replaces the multi-AZ RDS database instance. And if we use a feature called Global Tables that automatically replicates our database across multiple regions, we can get an availability of 5 nines, 99.999%. Not bad. If we multiply the availabilities of each, however, we get about 99.85%. That works out to about 13 hours of downtime annually. Contrast this with 99.9% availability, which gives us about 9 hours of downtime per year. So the availability isn't much better than what we can achieve with our traditional application architecture, but it's not much worse either. The real advantages of building a cloud-native application are scalability, performance, and in some cases, convenience. The disadvantages are you're locked into the cloud and your availability is slightly lower than what you could achieve with a traditional architecture. There is, however, a silver lining. If you're willing to put forth the time, effort, and money, you can achieve higher availability by simply deploying your cloud-native application in multiple regions. If we deploy our hypothetical cloud-native application in 2 regions, we can achieve an availability of 5 nines. How did I get that? 100% minus 99.85% is 0.15%. And if we multiply 0.15% times itself, we get, ready for this, 0.000225%.
Subtract that from 100 and you get 5 nines. That comes out to about 5 minutes of downtime per year. You're going to pay for it. You are going to pay for it, but it is achievable.